Chapter 4. So we're going to first talk about samples and surveys. Alright, the first thing we talked about in this chapter is we distinguish between a population and a sample. So in a population, that's the entire group of individuals or objects or whatever about which you want the information. The sample is the part of the population which you actually collect the information from, okay? And we always, going forward, we use the sample to infer things about the population. Just thinking about when you are, if you're ever asked on an AP question to, talk about your population or your sample or whatever, make sure you're describing it exactly as you want it. So, is it all U.S. adults or all female adults ages 18 to 24? Just be very specific when you describe a population, and likewise a sample. Just what are you measuring from that? So make sure you're very specific about that. And then how are you going to pick the sample from the population? So we have some choices here, and you want to make sure that you're clear in your explanation of that. Remember, there's ways to sample badly. So one way to sample badly is just doing convenient samples, so just sampling people that are easy to collect. So if I just stood outside my classroom and just talked to students that walked by, it would be convenience. That sample is not going to be representative of my population, and then that design would be biased because it's systematically favored certain outcomes. Voluntary response samples are ones in which people choose to respond to themselves, and it's usually they're biased because people with strong opinions respond. So anytime you see like an internet poll or something like that, like if you go online and you just want to respond to the internet poll, then you're doing a voluntary response sample. So the best way to sample is to do a random sample. So we talked about just, your basic random sampling, so using some sort of chance to select your sample. So we had a simple random sample. Remember, we abbreviated that SRS of size n consists of n individuals from the population chosen in such a way that every set of n individuals has an equal chance to be the sample actually selected. We can either use our calculator or computer, but we also used a table of random digits. So remember that random digit table had digits 0 through 9. Each entry is equally likely to be any of the 10 digits. The entries are independent of each other. Whenever we did that, we always first labeled everybody. So we would give each member of the population the numerical label of the same length. Remember, always try to pick the smallest label possible. So if you can get away with a 1-digit label, then use that. If you can use 2, then use 2. We read the digits, read consecutive groups of digits from the appropriate length on table D. Make sure you also mention if you were going to ignore repeats or what other labels you would be ignoring. So as an example here, they're choosing an SRS of 4 hotels. This is the line in the table. These all already labeled with 2 digits. So I'm just going consecutively. I don't have a 69. 05 would get chosen, and so on. So I would just keep going through the list to figure out which ones are going to be chosen. That 17 is going to get skipped here because we can't select repeats. If you finish the line and you need to select more, then you'd go on to the next line. Alright, so when you're sampling, it's just, you're taking a simple random sample and moving on. There's other ways to sample too. So one thing we talked about was a stratified random sample. So we first classified the population into groups, which we called stratas here, and then we chose a separate SRS from each strata. Another way we did it was we did a cluster sample. So first we divide the population into smaller groups. Ideally, the cluster mirror the characteristics of the population, and then we choose an S of the clusters. So we can talk about this a little bit here. So if we wanted to do a simple random sample of these seats here, we could just put them all into a hat and just pull out 80 of the students. If we wanted to do a stratified random sample, then maybe we have these stratas of groups, so we have them by grades, and I'm going to maybe take so if I want 80 in total, I'm going to take 20, a simple random sample of 20 from each grade. If I did a clustered sample, which probably isn't going to be ideal here, so if we had all of our 12th graders, so in a cluster sample, what I would do is I would randomly select maybe 2 of these groups or 3 of these groups. So let's say I randomly get the 12th and the 9th grade, and then I would take all the students in that group. Again, what's probably going to be an issue here is I'm going to get more than 80, so I maybe need to redefine. Maybe I cluster them by seats or something like that just to ensure I get the 80. But the easiest way for me to explain it to you right now is that you randomly are selecting the groups when you do the cluster, and then you take all the people. With stratified, you're taking a random sample from all the groups. Alright, so when we take a sample, we're going to eventually use that to infer something about the population. We use random sampling to eliminate the bias in there, and also to minimize our margin of error. Larger samples are always better than smaller ones. So things can definitely go wrong. So we could have undercoverage, so that occurs when some groups in the population are left out of the process when choosing the sample. Non-response occurs when an individual chosen for the sample can't be contacted or refuses to participate. A systematic pattern of incorrect responses in the sample survey, so it leads to response bias, and also the wording of the question can influence our results. So that is it for the first part of chapter